Okay, I'm going to go over a couple of questions on the force math for those people who weren't here for that. We'll start out with question one on the handout. It says an African elephant reaches a height of 13 feet, has a mass of 6,000 kilograms, and we want to determine the weight of the elephant. Well, our formula for weight comes right from the symbol, really. So force mg is the way we represent weight, because it is the mass times gravity. So it is very simple. Mass times gravity. The mass of this elephant is given to us as 6,000 kilograms. And gravity is given to us, as always, as 9.8. So then we just plug in the numbers and solve for its weight, which is its force of its mass times gravity. 6,000 times 9.8. You can certainly do that math, so I will not bother with that, but it is going to be somewhere in the neighborhood of a little less than 6,000 or 60,000 newtons. So I'll let you do that math. Meanwhile, it says calculate your own mass in kilograms and your weight in newtons. Alright? First of all, let's not forget the second part here. It wants us to convert these newtons into pounds, which you'll have to do for your mass too. So to convert these newtons into pounds, that's just a conversion problem, and we give you 1 pound equals 4.5 newtons. So we're going to start out, this is going to be in newtons, so guess we're going to have to do that math after all. I'll just round it to 60,000 newtons here. So 60,000 newtons, and then we're going to multiply by this conversion factor. And conversion factors can go, the pounds can be on the top or the newtons can be on the top. And the way that I have taught you to remember that is to remember a clever little rhyme that I came up with, which is find over given is the physics way of living. It's a handy little rhyme. It'll save you every time. So what that means is we want to put the unit that they want you to find on the top. It's find over given. So the find unit is over the given unit, and then the numbers that go with them. 1 pound, 4.45 newtons. So that means you will take the 60,000 divided by the 4.45, or you can multiply by 1 over 4.45. You get the same thing, and that will give you your answer in terms of pounds. So I will let you go ahead and do that math on your own, and you can come up with the answer. Now the next part here, part B, we'll do that one down here. It says your mass in kilograms and your weight in newtons. Most of you will know your weight in pounds. So the first step will be to convert your weight from pounds into newtons, and you will do that just exactly. Let's say you weigh 100 pounds. You will multiply that by the conversion factor, and this time the newtons is what you want to find and the pounds is what you're given. So again, find over given. So you're going to multiply this time by the 4.45 over 1, and that's going to give you your pounds. So if you weighed 100 pounds, you would be 445 newtons as far as your weight goes. And then to find your mass, you now have your weight, which is your force mg. So that is your mass. Your weight is force mg. So in this case, the scenario that I'm using is 445 newtons. That's his force mg. And force mg is mass times gravity. So if I want to solve for the mass, I just take and divide through by the gravity. So I'm just going to take this 445. So I'm going to take the force mg, divide out the g, and that'll give me the mass. Alright, that cancels out the g, that leaves me the mass. So I'll take 445, divide by 9.8. and that's going to give me the mass. And you know it's going to be somewhere around 45 kilograms or something like that. You can do that math and figure that out on your own while I move on to question 2. Okay, question 2 basically gives us another weight in pounds, and actually it then converts it into newtons for us, so that's very nice. And it wants us to solve for the mass. We do that exactly like we did the last time, right? Force mg, the last question asked for the same information, is going to be equal to mass times gravity. This is the force mg. Your weight is your force mg. So his force mg is 1300 newtons. So here I'm going to just divide out by the gravity to get the mass. So in this case my mass will be equal to my 1300 divided by the 9.8, which is gravity, and whatever that ends up being, you can do that. And then determine the normal force. This is even easier. This hopefully you remember from the free body diagrams. In terms of a free body diagram for an object that is standing, sitting, resting, not accelerating, basically the formula is that the force normal is going to be equal to the force mg. So whatever you get, well, right here the 1300 force mg, that is your force normal. So your force normal in this case is the 1300 given to you by the question. Not really a calculation, mostly just to make sure that you remember this. This is important for you to remember. You're going to use that throughout the unit. Okay, one more and then we will move on, because these are all pretty redundant, pretty much the same thing. You got two masses here. They're going to ask you to solve them in terms of their weight in newtons, I believe. Let's see, how much less does it weigh? So yeah, we can solve for the weight in newtons the same way we've been doing. Weight in newtons is FMG, force mass times gravity, mass times gravity. So in both of these cases we can do the 540 times 9.8 and then the 1440 and 50 times the 9.8, and that's going to give us the weight of both of these, and we can make our comparison. So there you have a few of the force questions. The rest of them are pretty much the same thing. Again, we're given a mass. They want us to determine, this time they want you to determine the mass of the guy on the moon and his weight on the moon. So all they did here is mass doesn't change, so that's just making sure you understand the idea that mass is the same everywhere. The weight on the moon, if weight is mass times gravity, and we change the gravity from the Earth's gravity of 9.8, 1/6 of that would be divided by 1/6. So that means the moon's gravity is 1.6. So then you're just going to use 1.6 as your multiplier. And so you'll take 98 times 1.6, and that'll give you his weight on the moon. And again, the normal force is the same as the weight for an object that is not that is at rest, standing there. So that would be how you would do that one. Again, here we're given the player's mass and an acceleration. Asked to solve for a force. Force is mass times acceleration. So you just multiply the two. 6 times 740. Moving on. Here is an acceleration. Here's a mass. Solve for the net force. Exactly the same as the last one. Not even going to bother. Here we have a mass. We have a force. Asked to solve for the acceleration. Okay, piece of cake. If force equals mass times acceleration, divide out by the mass, you get the formula for acceleration, which is Force divided by mass. Got the force divided by the mass. Boom. Answer. Done. And so on and so on. And these are just pretty redundant. Every once in a while they'll give you an old school acceleration one. Just remember your old formula for acceleration that we used in kinematics, which is velocity final minus velocity initial divided by time. So in this case, it's just going to be final minus initial divided by time. And that's going to give you your acceleration. You'll divide, and then force times, or mass times acceleration is going to give you the force. So, piece of cake. Have fun with these, and have any questions, see me in class, or see me at tutorial times.